Okay, we're going to take a look at the circle performance on Howe Two, specifically with regard to the areas of segments. That's the little piece that's left over when you have the area of a sector and you take away the area of a triangle. So this is the kind of document you're going to submit. Notice that there's a correct box on each of these problems, and you'll have 20 exercises total. You'll have 10 sector problems followed by 10 segment problems. The sector problems are easier, so I would do those first. And I'm getting reports that there are some problems with the software, so I'm going to do a couple and see if I can find those problems. Alex Blackwell found a problem with one of these games last year when she took it, and it could have been this game. So let's see what we can find out. We have a sector. Didn't just read that important message. I wonder how important it was. So I'm going to hit end and I'm going to go back. Maybe it said something about the potential problem. Okay, the angles and radii used in these problems will be chosen to make the arithmetic easier. Well, that's good. So we're going to get 3s and 9s and 4s and things that are easy to square. Make sure you understand the principles used in each problem so that you'll be able to answer problems that do not simplify as readily. So, 36, it's divisible by lots of numbers. So 36 pi would be an easy one to work with. So that is what they're saying there. I want a segment problem. So let's get out of here. Go to sectors and segments and ask for a segment problem. So it would be nice if it let me write on here, but I don't think it's going to do that. So let's find the space to write on. Let's see if I can minimize that. Okay. Here we go. So you're going to create the circle and you're going to start a menu. Now the menu is the quick part. If the radius is 18, the diameter is 36. That's just two 18s. The circumference is 36 pi. That's simply the diameter multiplied by pi. The area then is 18 squared multiplied by pi, and this is the area of the circle. 256, 289, is that 324? Yes, so the area of this figure is 324 pi units squared. So that's all you're doing for the menu, and you're kind of done. So then you're going to set up a proportion. 60 is to 360 as the area of the sector. We need the sector first. That's the wedge, or the pizza slice, is to the area of the whole circle. So this is 1/6 equals the area of the sector as compared to the whole circle. 6 times the sector equals the area of the circle times 1. So the area of the sector is 54 pi. And these are units squared. At this point, if you're not squaring your units, I don't know what to do. You really have to be squaring your units. 54 pi units squared. These are area units. And now I need the area of an equilateral triangle with side lengths 18. So this is a 60 this is a 30. So 18, 9, h equals 9 radical 3. So area of the triangle equals 18, that's my base, times 9 radical 3, that's my height, divided by 2. So that's 81 radical 3. So here is where we will enter these. I'm going to enter this as 54 pi. There's a pi button on your calculator. Minus 81 square root of 3. And I'm going to round the result to the nearest tenth. So, come on. 23.3 is what I'm going to enter here. And hopefully that'll work. Oh, that is not correct. Well, that's okay, because I just read my calculator wrong. So, it's not 23.3. 54 pi minus 81 radical 3 is 29.3. So let's fix that. And let's try that again. That is not correct. Okay, so I'm going to try one more thing. When I simplify 54 pi in the calculator, I get 169.65 or 169.6, and then I subtract from it 81 square root 3, I get 140.3. So let's go out to the hundredths place. 169.64, 140 point, we'll call that 29. And we get 29.35. So let's try 29.4. And let's check that. That is not correct. Help. Find the area of the related sector and subtract the area from the triangle formed. Subtract the area of the triangle formed between the two radii. Well, I did that. 1/2 base times height. Base is the radius. Height is the radius times the square root of 3. Height is the radius times the square root of 3 divided by 2. Oh, they're doing the area of this. Yeah, so all that makes sense. So, oops. I'm going to try a different one, and we'll just see what happens. So I have R equals 8, D equals 16, C equals 16 pi, A equals 64 pi units squared. I have a quarter of the circle. So 90 over 360 equals 1 over 4. So 1/4 equals the area of the sector as compared to 64 pi units squared. So 4 times the area of the sector equals 64 pi units squared The sector, therefore, equals 64/4 pi units squared. 16 pi units squared is the area of the sector. So area of the triangle then. We have a 90, we have a right triangle, that's nice, and it has r equals 8. And we may as well use this base as 8. So 64 base height divided by 2, 32 units. There's no pi involved in this triangle. So the area of the little piece left over, the segment, when we take the area of the sector and we subtract the area of the triangle, gives us 16 pi minus 32, 18.26 units. I believe they still want these to the 10th. Yep. Give decimal answers to the nearest 10th. So I'm going to enter 18.3. And check, and that is correct. So here I will take my screenshot. I'll edit, I'll copy, I'll insert it into a Word document. And I'll go ahead and shrink that so that I can fit 20. So, okay, that one worked okay. So let's try another one. Oh, well, here's my problem one again. So I'm gonna skip the one, skip the radius 18 problem. Okay, so menu R equals 6, D equals 12, C equals 12 pi. Area equals 36 pi units squared. I have 1/4. 90 over 360 is 1/4. The sector, that's compared to a circle that has area 36 pi units. I'm going to get 9 pi units when I do my cross products or bust the fractions. So 9 pi units is the area of the sector. I have a right triangle, that's handy because the base is the same as the height, so 36 is the area of the related rectangle, or in this case square. So 18 units is the area of the triangle. Area of the sector minus the area of the triangle. $10.27. Oops. Well, it took it to the hundreds place. That's interesting. I can't really explain that. It shouldn't have. It said nearest tenth. So I got about 40 seconds left. I don't know if I have time for a new problem, but this looks like a good one, so I'm going to try.